Hi guys, this is going to be a video for those of you that don't have Flash working on your computers. I'm going to run through the simulation. I'll go through the questions that are on the exit ticket one at a time, and I'll allow you to make observations. You can pause this video to read the readings, I guess, and be able to answer the questions on the answer ticket. So first off, let's just kind of get acquainted with our layout, our interface, in case you weren't able to yesterday. So we have, in this screen, we have the globe going around the ecliptic, or traveling along the ecliptic, which is the path that it takes around the sun. And that changes the time of year. You can also change the time of year using the slider down here. And the time of year, the specific date is given right here in this lower right corner. Up at the top, we have this person. We can change their latitude by moving them up and down the globe. So we can have them in the northern hemisphere, or we can set them on very specific latitudes that we want. So that, as you can see, will change the sunbeam angle where your latitude is. The other neat thing that you can do here is you can change this bottom one from the sunbeam angle to the sunbeam spread, and we'll do that towards the end of the exit ticket. The one important thing, one of the more important readouts, is the latitude right here, as well as the sun's altitude. So those are your two readouts that you'll really want to be paying attention to. Okay, so let's get started. We're going to pause the animation on September 20th. So I'll take my slider down here and find September 20th. Way over here, 18, 19, 20. Okay, what happens to the sun's rays as you move the person up and down the globe? So you're going to be taking a look at the sun's rays here, and what happens to them as you move them up and down the globe. That's interesting. So one thing is interesting is that from this perspective, when you're looking at the Earth from the side, the sun's rays are doing nothing. And that makes sense because the sun isn't going up and down. But down here, something is definitely changing about the way that an observer would experience the sun. Okay, question number 2. Pause this if you need to and fill in the answers on the exit ticket. Number 2, from which direction do the sun rays come from to a person in the northern hemisphere? So again, let's take a look at this screen, and if I'm in the northern hemisphere, as long as I stay north of the equator, which direction are all of those rays coming from? Number 3, which direction do the sun's rays come from to a person in the southern hemisphere? So now I'm going to go south of the equator, and something happens here. So what do you notice about where the sun appears in the sky? So if I was in the southern hemisphere, in order to look at the sun, I would have to look this way. I would have to look that way. And if I was in the northern hemisphere, in order to see the sun, if I were standing here on this grassy plain, I would have to look in this direction. So that tells you something about the direction that the sun appears in the sky. Okay, question 4. What is the highest and lowest possible value for the sun's altitude that a person can get anywhere on Earth, and what circumstances lead to these values? Okay, so I'm going to keep an eye on this, the sun's altitude, 54 degrees. So can I get this higher? All right, so if I go up here, that number is dropping. All right. Ooh, pretty high, 88, 89. Oh, that's like 90 degrees. Okay, pretty good. But what if I change the time of year? Oh, interesting. Okay, so it goes down. Can I get it? Oh, I can get pretty high there too. Can I get any higher? No. Oh, pretty high. That's interesting that happens right here. That's a very important latitude. Let me go over here. And I'm going to go up here and try to chase that number again. Ooh, there it is. Just about where I want. Oh, there it is. So interesting. So these two latitudes mean something, right? If I go north of those, let's just go back down. Okay, so that's my clue there. Something very important about these two latitudes right here. And you should know the names of those at this point. What's my next question here? Okay, what is the lowest possible value that I can get? Well, I don't want keep going down and down and down and down. Oh, I can only get to 23 there. Oh, okay. So I can get pretty low, but negative number, I mean, that doesn't make much sense. But yeah, that's about as low as I can get, isn't it? at least on this simulation. Okay. All right, question number 5. Oh, before that, New Canaan is located at 41 degrees north, so position the person at 41 degrees north. So I'm going to take my guy, I'll slide him up to 41 degrees north, somewhere right about here. Where are we? Where's my latitude? Ooh, we're pretty high. There we go. Oh, perfect. That's hard to do. So, okay, I'm glad that happened. Okay, what is the sun's lowest altitude? So I'm going to take my slider, I'm going to move it around. All right, got pretty low. Can I get lower? Lower than 20. Ooh, what's going on here? Can I get lower than that? Climbing up. Okay, so did you see it? Okay, I think we're there. What is the sun's highest altitude that hits New Canaan? So I'm going to keep my person at 41 degrees because that's the latitude from New Canaan, and I want to get the highest possible latitude. So let's try to get these rays as close to overhead as possible, as close to 90 degrees as possible. Keep climbing, 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 climbing. Higher, higher. Ooh, ooh. No, ooh, that's pretty high. Okay, so I think we hit our maximum there. Did you see it? Okay. What are they like today? May 13th. So let's go find May 13th. Right here. Oh, just passed it. 13. There we go. Okay, so we're pretty high. So if you look at those sun rays, it's pretty high, and you can read the reading right there. Not quite as high as they will get, but we're approaching that time. And then 2 months ago, when we first started quarantine, let's take a look at that. So let's go back to March 13th. Wow, quite a difference. So that's where we were when we first started. Look at how low those sun rays are basically hitting the equator almost at 90 degrees, maybe just south of the equator at 90 degrees. And they're climbing up. If you notice it, as you get closer and closer to getting out of school, they are climbing up. And we are about to get some pretty serious sun rays pretty soon. Okay, change the bottom right screen to sunbeam spread. Okay. And have the globe complete 1 year. So I'm going to start it here, and we'll go 1 year around. And we want to keep an eye on what's happening with the sunbeam spread. And then record what you see. Okay, that was 1 year. I'll go back. I'll do it again. Okay, and then lastly, when is a sunbeam spread highly concentrated? What time of year? Well, that's not it. So right about there. Okay, pretty good. Okay, so that should be everything that you need. If you have any questions, feel free to email me. Thanks.